In 2019, humanity photographed a black hole for the first time, and the world celebrated. Case closed, right? Wrong. Scientists quietly went back. They looked again, and what they found broke their own models. The magnetic field surrounding that monster had completely reversed direction. Something nobody predicted, something no simulation prepared them for. And that was only the beginning. New telescopes, new gravitational wave detections, and the James Webb Space Telescope have now revealed a terrifying truth. Everything we thought we knew about the environment around black holes was dangerously incomplete. This is the story they're still trying to explain. There is a photograph that changed history. You've seen it. A glowing orange ring wrapped around a circle of perfect darkness. The first image of a black hole ever captured by human beings. When the Event Horizon Telescope released that picture in 2019, it felt like a victory lap for science. Einstein was right. The math worked. The monster at the heart of the galaxy M87 looked exactly the way a century of theory said it should look. Textbooks were updated. Nobel-level celebrations followed. And most people moved on, believing the mystery was solved. But the scientists didn't move on, because deep inside that data, something was bothering them. The image was beautiful, but it was frozen. A single snapshot of an object that never stops moving. And a snapshot can hide things, terrible things. So the astronomers did what any good detective does. They went back to the scene. They compared observations from about 2017, from 2018, and from 2021. They lined the images up side by side, year after year. And that's when the entire picture fell apart. In 2017, the magnetic field swirling around M87's black hole spiraled in one direction. By 2018, they had settled into a more balanced pattern. And then in 2021, they reversed, spiraling in the opposite direction entirely. Read that again. The magnetic field structure around one of the most massive objects in the known universe flipped. Not drifted, not wobbled, flipped. One astronomer on the project admitted the polarization reversal between 2017 and 2021 was completely unexpected, saying it challenges their models and proves there is still much we don't understand near the event horizon. Think about what that means. This is not some minor detail buried in a research paper. Magnetic fields are not decoration around a black hole. They are the machinery. The changing polarization over time points to an evolving turbulent environment where magnetic fields play a vital role in controlling how matter falls into the black hole and how energy gets launched back out. In other words, the fields decide what the black hole eats and what it violently spits back into the galaxy. If those fields can reverse without warning, then the engine at the center of M87 is far wilder than anyone assumed. Let's put this monster in perspective, because the scale matters. M87 sits roughly 55 million light-years from Earth, and the black hole at its core weighs more than 6 billion times the mass of our Sun. 6 billion suns compressed into a region of space-time so extreme that light itself cannot escape. Its event horizon is larger than our entire solar system. Everything you have ever known, the Earth, the Sun, every planet, every spacecraft humanity has ever launched, would fit inside its shadow with room to spare. And the environment around this thing just demonstrated that it can reorganize itself on a timescale of a few years. In cosmic terms, that's not slow change. That's a heartbeat. But here's where it gets stranger. While the polarization was flipping, one thing refused to change. The size of the glowing ring itself stayed consistent across all the years of observation, exactly as Einstein's theory of general relativity predicts for the black hole's shadow. So picture the contradiction scientists are now facing. The black hole itself is behaving perfectly, obediently, exactly as the equations demand, but everything around it, the superheated plasma, the magnetic architecture, the flow of doomed matter, is chaotic, restless, and constantly rearranging itself. As one of the study's leads put it, the magnetized plasma near the event horizon is far from static. It's dynamic and complex, pushing theoretical models to their limit. The prisoner is calm, the prison is on fire. And the 2021 observations revealed something else, something astronomers had been hunting for years. 2 new telescopes joined the network that year, Kitt Peak in Arizona and Noema in France, sharpening the array's sensitivity. And for the first time, the EHT was able to constrain the emission direction at the base of M87's relativistic jet, a narrow beam of energetic particles blasting away from the black hole at nearly the speed of light. Stop and absorb that. A jet launched from the edge of a black hole moving at almost light speed, stretching thousands of light years into space, and for the first time, we can see where it connects to the ring of fire around the event horizon. Scientists detected signatures of extended jet emission near the jet base, right where it meets the ring around the black hole. We are, quite literally, watching the barrel of the largest gun in the universe from the inside. Why does that jet matter so much? Because jets are how black holes reach out and touch the rest of the universe. A black hole's gravity, as terrifying as it is, only dominates a relatively small region of its galaxy. But its jets, those can punch through an entire galaxy and beyond, heating gas, halting star formation, reshaping the evolution of hundreds of billions of stars. Recent modeling of M87's jet suggests it is threaded by a large-scale ordered helical magnetic field, a colossal corkscrew of magnetism winding through space. The black hole isn't just destroying matter, it's sculpting its entire galaxy, and we've only just found the trigger mechanism. Now, you might be tempted to think this is just one weird black hole, one anomaly, one bad neighborhood in the cosmos. That would be comforting. It would also be wrong. Because while the Event Horizon Telescope was watching M87 misbehave, other instruments were uncovering something even more disturbing. Not just about how black holes behave, but about how they exist at all. Enter the James Webb Space Telescope. When JWST began staring into the deepest, oldest corners of the universe, it started finding strange objects that astronomers nicknamed little red dots. Small, bright, extremely distant objects that the telescope has been routinely discovering since it began observations. At first, they were a curiosity. Then, astronomers looked closer, and inside some of these dots, they found supermassive black holes that should not exist. In November 2025, astronomers revealed a voraciously feeding, rapidly growing supermassive black hole at the heart of a galaxy called Canix LRD Z8.6, existing just 570 million years after the Big Bang. 570 million years. That sounds like a long time, but in cosmic terms, the universe was a newborn. And yet, here was a giant, already massive, already feeding, already fully formed. It's like finding a fully grown blue whale in a puddle that formed yesterday. The math of how black holes grow simply doesn't allow for this. And this is where everything changes. Because in 2026, it got worse. Astrophysicists studying an object called Abell 2744 QSO1, a prototypical little red dot, found a black hole so massive sitting inside a galaxy so chemically primitive that the authors openly stated most models cannot account for such a chemically unevolved system hosting a black hole that is already so massive. The discovery is a direct challenge to what we thought we knew about supermassive black holes. Because the standard story says a massive star collapses into a black hole at the end of its life, and then that black hole slowly grows over billions of years by devouring gas and merging with others. Slowly. Over billions of years. These objects didn't get the memo. They grew impossibly big, impossibly fast, in environments that hadn't even had time to build the ingredients. So now scientists face two crises at once. The environments around black holes are more turbulent and unpredictable than our best simulations. And the origin of the biggest black holes may not follow the rules we built our entire theory of cosmic history on. But the universe wasn't finished humiliating our models. Because a third revolution was unfolding. Not in light, but in the fabric of space-time itself. Gravitational waves, ripples in reality created when black holes collide. Since the first detection in 2015, these signals have become our only way to hear black holes that emit no light at all, the invisible population. And in July 2026, the floodgates opened. Astronomers released the largest gravitational wave catalog ever assembled, adding 161 newly identified black hole collisions and pushing the total number of detections to 390, revealing a hidden population of black holes, 390 cosmic collisions, each one a cataclysm that briefly shook the entire universe. And buried inside that data are black holes with masses, spins, and pairings that don't match the tidy categories we invented for them. But one signal stands apart from all the rest. Late last year, LIGO detected an unusual gravitational wave, and it may represent the discovery of a subsolar black hole. A black hole smaller than the sun. Here's why that should stop you cold. Ordinary physics cannot make one. A dying star simply doesn't have enough mass to collapse into something that small. Which means, if this detection is confirmed, that object was not born from a star at all. It was born from the universe itself. An unusual gravitational wave signal has renewed hopes that primordial black holes, long considered purely theoretical, may finally be within reach of discovery. Primordial black holes, objects forged not in stellar death, but in the first violent fractions of a second after the Big Bang, when the universe was so dense that random fluctuations could collapse directly into black holes. For decades, they were a fringe idea, a theorist's fantasy, and now there may be a signal. If confirmed, these hypothetical objects, which could range from asteroid size to massive, could explain a lot, including the nature of dark matter. Let that sink in. Dark matter, the invisible substance making up most of the mass in the universe, the greatest unsolved mystery in physics, might be black holes, trillions of them. Ancient, silent, everywhere. The environment around black holes isn't just complicated. The environment of the entire universe might be a black hole environment. And while observers were drowning in anomalies, the theorists dropped a bombshell of their own. For 50 years, physics has been haunted by the black hole information paradox, the terrifying possibility that black holes destroy information forever, violating the deepest laws of quantum mechanics. Stephen Hawking spent decades wrestling with it. Nobody solved it. Then, in July 2026, a new proposal landed. Researchers proposed that black holes stop evaporating at the very last moment, leaving behind tiny remnants that preserve all the information they ever contained. If that's true, then every black hole in the universe is not a destroyer. It's a vault, a permanent, indestructible archive of everything that ever fell in. The universe doesn't delete, it remembers. Now step back and look at what's actually happening here, because most people are not seeing the pattern. Individually, each of these discoveries is a headline that appears for a day and vanishes. But connect them, and a much bigger story emerges. The magnetic fields around black holes flip when they shouldn't. Jets launch from regions we're only now beginning to resolve. Giant black holes exist at cosmic times when they should be impossible. Black holes smaller than stars may be drifting through space, relics of creation itself. And the information paradox, the deepest crack in modern physics, may hinge on what black holes leave behind. Every single one of these threads leads to the same conclusion. The environment around a black hole is not a simple, predictable machine. It is the most complex laboratory in existence, and we have been reading it like a children's book. This is not chaos, this is a message. And the message is that our models were built on snapshots of a universe that never stops moving. Consider how we got here. For most of scientific history, black holes were pure mathematics, solutions to Einstein's equations that even Einstein doubted were real. Then came X-ray astronomy, and we found stars orbiting invisible companions. Then came the discovery that nearly every large galaxy, including our own, harbors a supermassive black hole at its center. Each step, we told ourselves we finally understood. In each step, the universe revealed another layer. According to general relativity, a black hole's exterior is extremely simple, while its interior holds the failure of the theory itself. That sentence from leading physicists in the field is one of the most quietly terrifying admissions in modern science. The equations that describe everything, gravity, orbits, the bending of light, break down inside every single black hole. There are billions of them in our galaxy alone. Billions of places where physics, as we know it, simply ends. And the environment just outside that breaking point, the swirling, magnetized, superheated frontier we're now finally imaging, is the closest we will ever get to touching that failure. That's why the M87 polarization flip matters so much. That's why the jet-based detection matters. We are not just taking pretty pictures. We are performing surgery on the edge of known physics. Here's what the new observations actually suggest about that edge. The plasma spiraling toward M87's event horizon isn't a smooth, orderly whirlpool. It's a battlefield. Magnetic fields grow so intense near the horizon that they can physically fight back against gravity, choking the inflow of matter, storing colossal energy, and then snapping, releasing eruptions that can outshine entire galaxies for brief moments. Some models suggest the fields near the horizon periodically become so dominant that they arrest the infalling matter entirely, building pressure like a cosmic dam until it breaks. A reversal in the observed polarization pattern could be a fingerprint of exactly this kind of violent magnetic restructuring. If so, then what the Event Horizon Telescope captured across 2017, 2018, and 2021 wasn't random noise. It was the slow-motion footage of a magnetic war. And our own galaxy is not exempt. Sagittarius A, the 4 million solar mass black hole at the center of the Milky Way, is a smaller, faster, more erratic beast. When the EHT imaged it, the plasma around it was changing within minutes, so fast that taking its picture was like photographing a toddler mid-tantrum. Flares erupt from its vicinity regularly, some detected in infrared and X-rays, rippling through the gas just outside the horizon. 26,000 light years from where you're sitting right now, a supermassive black hole is flickering, flaring, and rearranging its magnetic environment, and we still cannot fully predict when or why. Now think about the consequences, because this is bigger than astronomy. Black holes are not isolated monsters. They are the architects of galaxies. The jets and winds they launch regulate how much gas can cool and collapse into new stars. Turn the black hole's engine up, and star formation across the galaxy can shut down. Turn it off, and the galaxy overproduces stars and burns through its fuel. The reason our Milky Way looks the way it does, the reason there was a stable galaxy in which a quiet star could form with a small rocky planet with liquid water with you, is partly because of how the black hole environment at its center behaved over billions of years. If we don't understand That environment, we don't fully understand why we exist. That is not an exaggeration. That is the actual scientific stakes. And the discoveries about the early universe raise an even sharper question. If supermassive black holes were already enormous a few 100 million years after the Big Bang, before their galaxies had time to grow, then maybe we have the story backwards. Maybe galaxies didn't build their black holes. Maybe, at least sometimes, black holes came first, seeds of darkness around, which galaxies assembled like pearls around grit. Some theorists now seriously discuss heavy seeds, gigantic clouds of primordial gas collapsing directly into black holes of tens of thousands of solar masses, skipping the star stage entirely. Others point to those primordial black holes from the universe's first second. Either way, the little red dots, JWST, keeps finding are forcing a rewrite of Chapter 1 of cosmic history. Not a footnote. Chapter 1. Meanwhile, the census of black holes keeps exploding in ways nobody scheduled. In 2025, a series of studies shed new light on intermediate mass black holes, the long-missing middle children between stellar black holes and supermassive giants whose very existence was debated for decades. The gravitational wave catalogs are now revealing populations and mass ranges that stellar evolution supposedly forbids. Every time we build a more sensitive instrument, the universe responds by showing us black holes we said couldn't be there. At some point, you have to ask, is the universe strange? Or were our assumptions just small? So where does this go next? The machines being built right now will make today's discoveries look primitive. The Event Horizon Telescope collaboration is working toward expanded arrays and higher frequencies, the kind of upgrade that already in 2021 let us glimpse the jet base for the first time. The long-term dream is not photographs, but films, real-time movies of plasma orbiting the event horizon, magnetic eruptions caught as they happen, the black hole's environment rendered not as a frozen ring but as a living storm. On the gravitational wave side, Cosmic Explorer, a ground-based observatory now in its design phase, will be 10 times more sensitive than LIGO, capable of detecting black hole and neutron star mergers all the way back to the era of the very first stars. Every black hole collision since the dawn of starlight, audible, the complete fossil record of darkness. And when those instruments switch on, one of two things will happen. Either the anomalies will resolve, the flipping fields, the impossible early giants, the forbidden masses, will all click into a new, deeper theory, and we'll finally understand the engine at the heart of every galaxy. Or the anomalies will multiply, the cracks will widen, and we will be forced to confront the possibility that general relativity and quantum mechanics, the two pillars holding up all of physics, cannot be patched together at the edge of a black hole. That the event horizon is not just a boundary in space, but a boundary in human knowledge itself. Here is the uncomfortable truth underneath everything you've just heard. For a century, we treated black holes as the simplest objects. In the universe, pure mass, spin, and charge, nothing more. Elegant, clean, solved. And in barely 5 years, that illusion has been dismantled by flipping magnetic fields, impossible ancient giants, phantom subsolar objects, and 390 collisions echoing through space-time. The black hole itself may be simple, but the environment around it, the storm of plasma, magnetism, and warped space-time, where matter takes its final breath, has turned out to be one of the most complicated systems ever observed. We didn't solve black holes in 2019. We opened the door. And something on the other side is far bigger than we imagined. So the questions remain, and they should keep you up at night. Why did the magnetic fields around M87 reverse, and when will they reverse again? How did black holes billions of times the mass of the sun exist when the universe was still an infant? Is dark matter, the invisible skeleton of the cosmos, actually an ocean of primordial black holes older than the stars? And if black holes truly preserve everything they consume, leaving behind eternal remnants of information, then somewhere out there, in the frozen archives of 1 trillion dark vaults, is the universe keeping a record of everything that has ever happened, including us. The telescopes are still watching, the detectors are still listening, and the next signal, the one that changes everything again, may already be on its way.